So section 7.5 on page 521 is about complex rational expressions. So we're going to start with example 2. So I'm going to show you with an example how to solve these complex rational expressions. So it's just about notation. So example 2 on page 523 is about simplifying. So we're going to simplify this a complex rational expression. So we have 1 plus 1 over x, and then we have 1 minus 1 over x. So this is a complex rational expression. It is complex just because we have a big numerator. So essentially the numerator is a rational expression, and then we have the denominator is another big denominator because it is also another rational expression. So a complex rational expression is just a fraction where the numerator is a rational expression and the denominator is another rational expression. To solve these problems, we're going to divide our work in two parts. We're going to work on the big numerator and we're going to work on the big denominator apart, and at the end we're going to combine everything. So first, remember, we're going to enclose in parentheses our numerator and our denominator. So the next thing that we're going to do is we're going to use different notation. So you identify the main fraction bar. So this is the main fraction bar. This is the main fraction bar. We're gonna rewrite the complex rational expression by replacing the main fraction bar with the symbol that we have used before for a division. So if you write this complex rational expression by using this symbol, we're going to write the following. We're going to have 1 plus 1 over x, which is divided by 1 minus 1 over x. So I have my numerator, I have my denominator. So I'm going to simplify the numerator. I'm going to simplify the denominator, or I'm going to perform the indicated operations. So what I want at the end of the day is just a simple fraction, a simple rational expression for the numerator, and a simple rational expression for the denominator. Here we have two rational expressions, remember? Here we have another two rational expressions. I need only one for the numerator and another one for the denominator. So let's start with the numerator. So the big numerator is just 1 plus 1 over x. So we need to work on this addition of two rational expressions. So remember, we need two fractions. So we're going to divide the first one by one, just to have now two fractions. Then we're going to add these two fractions. So we need the least common denominator. The least common denominator for these two fractions is the first denominator times any other factor that you're going to find in the other denominators that is not already in the first denominator. So x is a factor that is not contained in the first denominator. So my least common denominator is just x. So we're going to write this. Remember, we have 1 over 1. We're going to multiply both the numerator and the denominator of the first fraction, and also we're going to multiply both the numerator and the denominator of the second fraction by something. And in the first case, I need to get at the end of the day the least common denominator in every denominator. So what is the factor I need to use here to convert this denominator into x? So I need to multiply by x, right? Because I have 1 times x is going to give me x. But if I multiply this denominator by x, I need to multiply also the numerator by x. So now I have this denominator to be now my least common denominator. Now in the second case, I need to multiply x by what to get x? The only possibility is 1, because x times 1 is going to give me x. If I multiply by 1 the denominator, I need to multiply by 1 the numerator. So now I have two fractions with the same denominator, something that I didn't have before. That's the reason we look for the least common denominator, because our denominators were different. So when the denominators are different, we need to look for a least common denominator. Once you get your least common denominator, you need to convert the fractions to other fractions that are going to contain the least common denominator as their denominators. Now that you have the least common denominator for every fraction, then you're going to add or subtract. It depends on what is the sign in between. But now you have common denominator. The common denominator is just x times 1, which is just x. And then you just add the numerator. So you're going to have x plus 1. So this is now my big numerator converted into a simple rational expression. Why is this a simple rational expression? Because this is only one fraction. Before we have two fractions in the numerator, now we have only one fraction. So we're going to do the same thing now with the denominator. So I have my big denominator. So I have 1 minus 1 over x. So I have two fractions because this one is 1 over 1. And I need to get only a single fraction. So again, these are different denominators. So I need to look for a least common denominator. And it's going to be obtained by multiplying the first denominator and every other factor from the other denominator that is not already included in the previous factor. So in this case, it's just x. So my least common denominator is going to be again x, as in the first case. So now I'm going to rewrite the fractions, but I'm going to multiply each by quantities that are going to make both denominators equals to the least common denominator. So what is the factor that I need to use here that is going to multiply 1 to get the least common denominator? So what I want to have here is just x, because x times 1 is going to give me x. And then if I multiply by x here, I need to multiply by x over here. The same thing here. I already have x here, so the only factor that I could use is just 1. So now I have the subtraction, the difference of two fractions with the same denominator. So when you have the same denominator, you just write the denominator and you write the numerators in the way that were ended from the previous step. So I have x minus 1. So this is my big denominator already converted into a single rational expression or single fraction. So now I'm going to rewrite everything. So I'm going to go back to this part here. So I'm going to rewrite this complex rational expression by using the new result. So the numerator is x plus 1 over x. So that's my big numerator. Then I have the denominator is x minus 1 over x. So now this complex rational expression looks different from the previous one, but is equivalent, is the same. So the next step is when you have the division of two rational expressions, remember, we're going to convert this into a multiplication. So the way that we do that is we're going to write the first rational expression the same without changing anything. Then we're going to use the operator for multiplication instead of the operator for division. And then we're going to reverse the second rational expression. So we're going to write, in this case, the numerator is going to become the denominator is going to become the numerator, and the numerator is going to become the denominator. So now I have my division becoming a multiplication. And then we're going to finish just multiplying. But remember, before multiplying, we can cancel every common factor from the numerator and the denominator. So we use parentheses to enclose every quantity to visualize better the factors. So what are the common factors? So you have this x that's going to go away at the same time that this x goes away too. So we end up only with x plus 1 in the numerator and x minus 1 in the denominator. So that's the final answer for this problem. So that was my first problem. We're going to solve more problems in the same way. So, and then you're going to just practice this a lot, and then we're going to move on to the next section. So I'm going to solve one more example. So the next example is from page 523. Is going to be example 3. So I have example 3 on page 523. So we're going to simplify. And we have 1 over xy over 1 over x plus 1 over y. So this is my complex rational expression. I'm going to identify the main fraction bar. So I'm going to, remember, I'm going to convert this into a different with different notation. I have my numerator, I have my denominator. So I'm going to write this by using this operator. So I'm going to have 1 over x y divided by 1 over x plus 1 over y. So then we're going to start working with simplifying every expression or rational expression that is inside of the parentheses. So the first one, the numerator, is already in a simple way because it's just a single fraction. It's a single rational expression. The second one is an addition, so I'm going to work with the big denominator only. So I'm going to add 1 over x to 1 over y. So you see, again, these are different denominators, so I need to find the least common denominator. I'm going to write the first denominator. I'm going to multiply that by any other factor from subsequent denominators. I only have y, which is different than x. So my least common denominator is going to be x, y. So I need to rewrite these rational expressions in a way that they are going to have the same denominator, which is xy, the least common denominator. So I need to multiply x by something to get xy. So I need to multiply x by y. So both the numerator and the denominator. I need to multiply y by something to get xy. Then it's x and x. So you see that it's not hard to do this. So now we have a common denominator, which is x times y, because y times x can be written as x times y. So it doesn't matter the order of the factors. The product is the same. And then we have the numerator, which is going to be y plus x, because y times 1 is y, and 1 times x is x, and we have this plus in between, so we need to incorporate that one into the numerator. So I have y plus x. So now I can rewrite my complex rational expression by using just simple fractions or simple rational expressions. The first one is already in a simple form. The second one is going to be y plus x over x y. Now we're going to convert the multiplication into the division into a multiplication. So the first fraction remains, the second fraction is inverted, and then to proceed with the multiplication, you're gonna cancel common factors. So I have xy here, so you can cancel those. You just gonna remove this pair of factors and this pair of factors. So strictly what we do is we cancel x, we cancel y with y, and then we end up with only 1 over y plus x. Y plus x can be written as x plus y, so maybe your book has 1 over x plus y, which is the same thing. So that's the answer. So now I'm going to solve 2 more examples, and then you're gonna work on this. So 2 more examples, so the process is the same. So I'm going to work on example 5 on page 525. So example 5 is another complex rational expression that we're going to simplify. Is 1 plus 1 over x over 1 minus 1 over x. So it looks like we already solved this one. So this is example 2. So the only difference that they are showing you in the book how to use the least common denominator method that we already did. So you're gonna see example 1. It's the same. So we don't waste time on repeating that. And also example 6. So this portion of the lecture is going to be shorter than expected. I was expecting a short lecture today, but now it's shorter because example 6 is 1 over x y over 1 over x plus 1 over y. So you're going to see example 3 because they're using in these 2 cases the least common denominator method that we already used previously. So what we're going to do is you're going to start solving examples, and if you find a problem with difficulties with some of the problems, let me know and I can show you how to solve one of the problems that you're going to start solving now. So we're going to start with 7.5 exercise set on page 526. So you're gonna solve 5 exercises. So it's a lot, but we have plenty of time to check your work. So please work on these problems and let me know your questions or your answers by using the chat box. So we're gonna start with problem 8. So it's just 2/3 minus x over 2/3 plus x. So you're gonna simplify all the complex rational expression I'm going to write. So the number 10 is just 8 plus 3 over x over 1 minus 7 over x. Then we have problem 24. Problem 24 is 1 over x plus 1 over y over x plus y. Then we have problem 30 is 8 over x squared minus 2 over x, and this is going to be divided by 10 over x minus 6 over x squared. And finally, the last problem that you're going to solve is problem 34, 1 over x minus 2 over 1 minus 1 over x minus 2. So 5 problems. I chose problems that are going to be very similar to the ones that you're going to find in the corresponding quiz and also in your final exam. Work on this problems and send me your answers by using the chat box or by submitting your classwork through Canvas by using the corresponding section. So in section 7.6, which starts on page 529, we're going to learn how to solve rational equations. So there is a definition on page 530 that says a rational equation. A rational equation, also called a fractional equation, is an equation containing is an equation containing one or more rational expressions. One or more rational expressions. Then on page 531, we have the steps to solve a rational equation. So the steps to solve a rational equation are the following. First, you're going to find the restrictions. Find the restrictions on the variable. And then we're going to multiply. We're going to find first the least common denominator of all rational expressions in the equation, and then we're going to multiply both sides of the equation, both sides of the equation by the least common denominator. Then after this step, there is no longer a rational equation. It's going to be an equation. It could be just a linear equation or maybe a quadratic equation. So you're going to solve the resulting equation. You're going to solve the resulting equation, and finally you're gonna remove from the solutions the restriction values. So those are going to be the steps that we're going to follow to solve a rational equation. So I'm going to start solving 2 or 3 examples, and then you're going to do the same. And that is going to be all for today. So next time we're going to solve applications involving rational equations. So let's see. I'm going to solve now example 2 on page 531. So we're going to solve 1 over x equals 1 over 5 plus 3 over 2x. So what is the first step? We're going to find restrictions. Find the restrictions on the variable. In this case, our variable is x. So what do we do to find the restrictions? You're going to equate every variable denominator to 0. So for example, I have this denominator here, x equals 0. Then I have this is not a variable, and then I have 2x equals 0. So I have 2 equations. You just solve this equation. The first one is already solved, x equals 0. In this case, you divide by 2, and you get also x equals 0. So the restriction is 0. So then you need to write this. This is the restriction. X cannot be 0. Then we're going to find the least common denominator for all the denominators that are here. So we're going to start with the first denominator. So the first denominator is x. Then we're going to multiply this by any factor in the second denominator that is not here. So 5. Then we're going to multiply by the factors from the third denominator that are not already here. So 2 is not here, but x is, so we don't need to multiply by x again. So our least common denominator is going to be 10x. Now, step number 3, we're going to multiply both sides of the equation by the least common denominator. So I'm going to write 1 over x equals 1 over 5 plus 3 over 2x. So I need to multiply both sides by the least common denominator, which is 10x. So I'm going to multiply 1 over x by 10x. That's the left-hand side. Then I'm going to multiply 1 over 5 by 10x. I'm going to multiply 3 over 2x by 10x. So now you simplify. We're going to simplify, and then we're going to solve the resulting equation. So let's see. In the first case, I have this x here and this x here, so they cancel to each other. So I end up with only 10 times 1 is going to be 10. Now on the right hand side, I have 10 divided by 5 is going to be 2, and x is going to stay there because there is no x in the denominator. Then in the next case, we have this x here cancels this x here, so they can be removed, and I have 3 times 10 is going to be 30. 30 divided by 2 is going to be 15. So that's the resulting equation. Then we're going to solve the resulting equation. We're going to solve the resulting equation. So the resulting equation is this. So you have 10 equals 2x plus 15. You're going to subtract 15 from both sides of the equation. So you get here minus 5 equals 2x. Then to remove the coefficient, you divide by the coefficient on both sides of the equation. So now you can cancel 2 and the coefficient here, 2 and 2, they can be removed. So you end up with x equals negative 5 over 2. So this is the solution. Then you compare the solution with the restriction. So this is the solution, and I have the restriction equals, the restriction is x different than 0. So there is no contradiction here. So your final answer is just x should be equal to negative 5 over 2. And that's the solution for this equation, for this rational equation. So I'm going to solve another problem. So we have now example 3. On page 532. So we're going to solve the following equation. Is x plus 1 over x equals 5 over 2. So I'm going to rewrite this in a way that I have only fractions everywhere. So I need to divide this by 1, then 1 over x equals 5 over 2. Then we're going to find restrictions. We're going to find restrictions by equating all variable denominators to 0. So this is not a variable. I only have this variable here, x equals 0. Then I solve this, and this is the only solution. So that means that x, so this is the restriction. And the restriction should be written in this way. X shouldn't be 0. Shouldn't be equal to 0. Now we're going to find the least common denominator. So I'm going to start with the first denominator, which is just 1. Then I'm going to multiply by the factors from the second denominator that are not already here. So x is not here yet. Then the next denominator is just 2. 2 is not here. So finally, my least common denominator is going to be 2x. Then I'm going to multiply both sides of the equation by the least common denominator. So I'm going to write my equation is x over 1 plus 1 over x over 5 over 2, and I'm going to multiply everything by 2x. So the first one is going to be x over 1, and it is going to be multiplied by 2x. Then the next one is 1 over x, and we're going to multiply this by 2x. And then 5 over 2, and we're going to multiply this by 2x. So you can see here now that we can cancel these 2 and these 2. And you can cancel this x and this x. So you end up with 2 times x times x is going to be 2x squared then plus, then I have here just number 2, then I have here 5x. So I'm going to end up with the quadratic equation. So you move this to the left hand side. So you get 2x squared minus 5x plus 2 equal to 0. And then we're going to need to solve this equation. So we're going to solve the resulting equation. So the resulting equation is just this one, this quadratic equation, 2x squared minus 5x plus 2 equal to 0. So we're going to start looking for numbers. If you get two numbers, like when you multiply them, you get a times c, which is just 4. And if you add those two numbers, you should get b, which is negative 5. So what are those numbers? Those numbers are 4 and 1. So they're going to be negative 1, negative 4. If you multiply negative 1 and negative 4, you're going to get positive 4. If you add negative 1 and negative 4, the addition of two negatives is another negative, so it's going to be negative 5. So that means that we're going to rewrite this and quadratic equation, this trinomial, and we're going to break the middle term by using these two numbers, negative 1, negative 4. So we're going to have 2x squared minus 1x minus 4x plus 2 equal to 0, 0. So then we're going to factor by grouping now. The greatest common factor here is going to be just x that multiplies 2x minus 1, and here the factor is going to be negative 2 that multiplies 2x minus 1. This is equal to 0. So I'm going to write the common binomial 2x minus 1 multiplying the binomial that is created by using the greatest common factor. So x minus 2 equal to 0. So now the final step is just working those linear factors independently to find the solution. So either 2x minus 1 is equal to 0 or x minus 2 is equal to 0. So let's solve this equation. So I'm going to add here 1 to both sides of the equation. So you end up with 2x equals 1. Then we're going to divide by 2. So the final answer on this side is going to be x equals 1/2. Then here you're going to add 2 to both sides of the equation. So you're going to get x equals 2. Then you're going to write the restrictions. The restrictions were x different than 0. So we're going to write that restriction here. So you check, this is not 0. So that works. This is not 0. That works. So the final answer is just 1/2 and 2. So those are the solutions for the given rational equation. So now we're going to work two more problems, and then it's going to be your turn. So we have example 4 on page 533. So we're going to solve the following rational equation. So it's just 3x over x squared minus 9 plus 1 over x minus 3 equals 3 over x plus 3. So we're going to find restrictions. To find restrictions, we need factors. We need to factor denominators. So in this case, this denominator, x squared minus 9, can be written as, and remember this is a perfect square, another perfect square. This is the difference of two perfect squares. So this is just x squared minus 3 squared. So this is a, this is b. So this denominator can be written as a plus b. So x plus 3 times x minus 3. So a plus b times a minus b. And the rest is going to be the same. So I'm going to rewrite this as 3x over x plus 3, x minus 3. That's my first rational expression. Then I have 1 over x minus 3. And this is going to be equal to 3 over x plus 3. So let's find restrictions first. We're going to find restrictions. So from this problem, we have a step 0. Step 0 is just factor denominators. That's our step 0. So step 0. Then step 1 is finding restrictions. So we're going to equate these denominators to 0. If you equate the first one, you have x plus 3 from here equal to 0 and x minus 3 equal to 0. So you're going to get minus 3 here. So you get x equals negative 3. And from here you're going to get plus 3. So you're going to get x equals plus 3. Then from this one, x minus 3 equal to 0 is this equation. X plus 3 equal to 0 is this other one. So there are only two restrictions. So these are our restrictions on the variable. Restrictions on the variable. How do we write restrictions? We use x different than, and then we're going to write negative 3 and positive 3. So these are the restrictions, meaning that you cannot use these values when you are dealing with this equation, because if you do that, you're going to get undefined results. So now we're going to find the least common denominator. So we already have our denominators in factor form. That's the reason this step is very important. So we didn't do that before because we didn't need to factor anything. Everything was in a factor form. So our least common denominator is factors from the first fraction is x plus 3 times x minus 3. Now, second fraction, x minus 3. Is this factor already here? Yeah, it is here. So we don't need to incorporate this factor again. X plus 3. Is x plus 3 over here? Yeah, it's here. So that's my least common denominator. It's just x plus 3 times x minus 3. So now we're going to multiply. We're going to multiply both sides of the equation by the least common denominator. So every piece, every fraction here is going to be multiplied by the least common denominator. So I'm going to write here 3x over x plus 3 times x minus 3 plus 1 over x minus 3 equals 3x minus 3. My least common denominator is x plus 3 times x minus 3. So I'm going to multiply this by this, and by this. So I'm going to multiply everything by my least common denominator. So let's start now. So I have here 3x Then I'm going to multiply by my least common denominator, x plus 3, x minus 3. And I have denominator x plus 3, x minus 3. So now you're going to see that having parentheses is very important, because you're going to be able to identify common factors, and also you're going to prevent from making mistakes. So that's my first rational expression already multiplied by the least common denominator. Now my second one. So I have 1, the numerator multiplying the least common denominator. So usually numerators are the ones that multiply the least common denominator. And then I'm going to write the denominator, which is just x minus 3. Then I have the equal sign. Then I have this numerator 3 that multiplies again the least common denominator, x plus 3, x minus 3, and then the denominator is just x plus 3. Now we're going to simplify things. So you're going to see that you're going to be able to cancel common factors. So here is very easy. This one and this one and this one and this one, they cancel to each other. So we'll remove that. So from this first step, you just get 3x. Then I have this plus here, and then let's see what is the remaining part from here. So you're gonna cancel x minus 3 and x minus 3. So you end up only with x plus 3 multiplying 1, which is just x plus 3. So you can use a parenthesis here, especially if you have a negative sign here. Since this is a positive sign, then you don't use parentheses. But I'm going to use it now for you to see that this is important, especially if you have a subtraction here, if you have a minus sign. Okay, then the rest. So I have here x plus 3 and x plus 3, they're going to cancel to each other. So you're going to get 3 that multiplies x minus 3. Now we're going to apply the distributive property here and here. And we're going to solve the equation. So we're going to solve the resulting equation. So when you get to this step, you need to check that you don't get denominators. If you still have denominators, then you need to multiply by that denominator, because that means that you didn't get the right least common denominator. The purpose of the least common denominator is trying to get rid of all denominators. But at the end, if you still get a denominator, just multiply by the denominator both sides of the equation. So in this case, I have 3x, then I have plus x plus 3 equals 3 times x is going to be 3x minus 3 times 3 is going to be 9. Then you can just subtract 3x from here and 3x from here, and then these two cancel, and you just get x plus 3 equals negative 9. Then you're going to subtract 3 from here and from here, so you're going to get x equals negative 12. So that's the solution. You need to compare this solution with the restrictions. The restrictions are negative 3 and positive 3. So there is no contradiction here. So negative 12 is not any of the restrictions. So the final answer is just x equals negative 12. So that's example 4. So now we're going to work the final problem. So the final problem is example 5. Example 5 on page 533. So now we're going to solve one more rational equation. So we have ax over x plus 1 equals 4 minus 8x plus 1. So we're going to include this denominator here to have fractions everywhere. So factoring denominators, the denominators are already in a factor form. There is nothing that we can factor out from this denominator. So that's our step 0. So factor denominators. That's fine, nothing to do. Then we're going to find restrictions. Restrictions are going to be obtained by equating variable denominators to 0. So we have here x plus 1 equal to 0. This is not a variable denominator, and this is again x plus 1. So I only need to solve this equation. So you subtract 1 from here, and you're going to get x equals negative 1. So this is the restriction. This is the restriction, and we're going to write that restriction as x should be different than negative 1. So that's the first step. Then the second step is going to be finding the least common denominator. So the least common denominator is just the first denominator, x plus 1. Then you multiply by any other denominator factor that is not here. So 1 is here, x plus 1 is here. So this is my least common denominator. So now step 3 is going to be, we're going to multiply both sides, multiply both sides of the equation by the least common denominator. So my equation is ax over x plus 1 equals 4 over 1 minus 8 over x plus 1. My least common denominator is x plus 1. So I'm going to multiply everything by this least common denominator. It's like applying the distributive property. So we start with the first one. You're going to have the first numerator ax that multiplies x plus 1 is the least common denominator, then the denominator that I already have here. So pay attention, don't forget what you already have in the equation. We are just multiplying by the least common denominator. So here we have 4 that multiplies x plus 1 over 1 minus 8 that multiplies x plus 1 over x plus 1. And again, it's important to use parentheses because you cannot cancel, remember, you cannot cancel this x with this x because these x's are not single factors. They are part of a factor. They are embedded in the factor. So you cannot remove this x only. So you need to remove the entire parentheses. So in this case, we're going to remove x plus 1 and x plus 1. We're going to remove x plus 1 and x plus 1. So we end up with ax on the left hand side. Then we have 4 that multiplies x plus 1 minus 8. That's what we ended up getting on this equation. So now we're going to solve the resulting equation. We're going to solve the resulting equation. So we have ax equal, we're going to apply the distributive properties, so you're going to get 4x plus 4 minus 8. So we're gonna simplify, so you're gonna get ax equals 4x, and 4 minus 8 is gonna be minus 4. Then we're gonna subtract 4x from both sides of the equation, so we're gonna get 4x equals negative 4. Finally, we're gonna divide by the coefficient of the variable that we are solving for. So you're gonna get just x equals negative 1. So this is the solution, and we need to check the restrictions. So the restrictions that we found for this problem is this one. So the restriction is negative 1. So we're gonna write here the restriction. So is the restriction equal to the solution? Are they the same? Yeah, in this case the restriction and the solution are the same. So that means that we cannot use negative 1 as a solution because it's already a restriction, so no solution. Why? Again, because the value that we found, negative 1, is already a restriction, so you cannot use it. So another way to indicate no solution is just the empty set. This is the empty set. This is like having x equals and then nothing inside. It's empty. But another way to write this is using this symbol. That's the empty set. So no solution. So now you're gonna work now problems from the exercise set. So you have 7.6 exercise set on page 536. So these are the problems that you're gonna solve. You're gonna start with problem 10. No, you're gonna start with problem 2. Okay, let's write problem 10 here because I already wrote this number. So you have 7 over 2x equals 5 over 3x plus 22 thirds. So that's problem 10. Then we have problem 14. So 7 over x plus 1 equals 5 over x minus 3. And then maybe 2 more problems, and that's all for today. So you're going to have plenty of time to work this after we finish our time here. So we have problem 28. Problem 28 is 3 over x plus 1 equals 1 over x squared minus 1. And finally problem 36, 10 over y plus 2 equals 3 minus 5y over y plus 2. So there are 4 problems here. Yeah, maybe one more for after school. 46 is just x minus 3 over x minus 2. So this is for you to get well prepared for the final exam. Plus x plus 1 over x plus 3 equals 2x squared minus 15 over x squared plus x minus 6. So these are the problems that you're going to solve now. You have plenty of time to solve these problems. I'm going to stay here until the last student finishes her work. And submit your solutions by using Canvas if you are not going to do it now, by using the chat box. And then we're going to continue the next time with the final section corresponding to chapter 7.